Alright, this here is our '07 Buick Lucerne with a 3.8. See right here, got our coils. It's a waste spark system. Down here, I don't know if you've seen the video, that's where your connector is. You're gonna need a diagram pin out. Take a look at that. It's like that. Easy access looks like this. Extra because lab vehicle. And then we've also removed the spark plug. Take a look. So cylinder 5 down here. Got her out right here. You can see it's not too bad, but little kind of a lot of fuel on it. That'll focus in. It's kind of dark and fuel soaked, but other than that, it's just because the lab vehicle, it gets fired up cold every time and shut off. But then we can show a picture of another one with an excessive gap and bad condition.
High mileage.
Alright, disconnected 2 plug wires right there. Do a quick resistance check on our coil on our secondary side. About 5,700 ohms, right what we tested in class on similar coils. We also did a quick resistance check on our spark plug. Test right on the tip of the electrode, on the tip of the spark at top of the spark plug, and that came out to about 7,000 ohms, which was on the high side for the specs given in class, but all the other plugs had the same resistance, so I'm sure it's fine.
And then quickly ran over. We got our gap here, which is 60 thousandths. And then we're going to torque those spark plugs back to 11 foot-pounds. Okay, so we've got our primary windings probed out on our coil. We're getting about 1.8, 1.9 ohms of resistance, which is in spec. And then I've also got pulled up over here our connector that connects into the distribution block for the coils. This is the pinout of it. Here we've got our Pico sheet. I'm going to come over and point out. So we got our yellow and our blue. Over here in the car, our yellow is our primary. We've got it probed out there, our primary coil. And then our blue was our second, was our little paddle that we put on the top of the coil so we could see what it was doing, and that's what we got going on over here. So you see on our primary coil, we have it open, it grounds, and it does something like almost like a peak and hold where it kind of almost fully like has like half of it, half the grounded kind of thing, and then it releases it and lets it shoot up to about 15, 17 volts, and then as it pitters off down here, it comes back down, and it goes on to the wait until it's turned again. And you can see that it follows here with our paddle. At the same time, once it grounds, it kind of drops down and tries to balance out, comes back, and you see right with that peak and hold style, it matches up here, and it does the same thing where it just shoots right off and then balances back out. It does a real big dip here. You can kind of see the dip up there, and it comes back and evens back out. And then if I exit out of here, you can see we've got these 2 little bumps that keep repeating. That is the other 2 coils that are firing. So here's the one we were focusing on, and there's the next one, and then the next one, and then the one we're focusing on, the next one, the next one. It just keeps going. Here you can see our dwell time, starting at 49 milliseconds and ending about 54 milliseconds. So about 5 millisecond dwell time. On this car, since it is a waste spark system with coils controlled by the PCM, it cannot be really timed by us. It has to be run through a computer first. It's not a simple timing procedure, and ALLDATA does not give any recommendations on how to do that. So now I'm going to hook up some resistors to the primary side of the coil to act as almost as like a corrosion or resist, or if salt or something got in there and corroded the terminals, because it looks like a very easy little spot for corrosion to happen that I could predict to see out in real life. Alright, so I've got the Picos paused here, car off and everything, so I could just talk about it. So here's our primary coil. You can see we're at about 100 millivolts without the dwell, attenuated. So it dwells for about 6 milliseconds. And then we see our peak, about 500. And then you see the oscillation, and it comes down, and then you can see it even picks up just a hair of the other cylinders firing. And this is our probe here. You can see the similar thing where it picks up when the dwell kicks in, and then immediately after it releases the saturated voltage there, and you can see each other cylinder picking up a little bit more as well. So I added another resistor. I'll get you the resistance value on this in a minute. We got them in parallel, and the car's way better running now. I didn't get a video of it, but it was like running on 4 cylinders before, but now it's running pretty smooth, and our misfire count over here is clean. However, if you look at the pico scope, if you're 3 and 6 is what we got, is what we're looking at. They're clean. Here in the pico, it looks pretty normal, but if you watch right here, you can see on our dwell, this car has like almost like a peak and hold when it normally is working. So I'm going to connect the two together, and you'll see this dwell change out just a hair. Little resistors here, measure them. So we're getting 3.7 ohms in parallel, with them wired in parallel here. However, this one was an 8.4 and this one was a 6.4 just alone. So that's why when we had just the one there, it ran rough because it had more resistance on that primary coil when we had, and compared to when we had 2, which now has less resistance. This whole experiment would then show the effect if I had, got some corrosion or salt or something, just some corrosion down on these, just to create enough resistance between those terminals and those terminals.